Page 549, problems 1 to 6, and the answer to the puzzle, farmer has 17 sheep and all but 9 die. How many are left? That would be 9. And then you can pass those in after your partner checks to see that you put your name on the back, you stapled, answer is circled. If the test was not finished yesterday during literature today, you need to finish that test. We have 2 sections to cover today. The first one is on fractional exponents. We'll go through the information on that, and then we'll do the odds to that one, and then come back and do the second part. Fractional exponents are written a to the 1/n power. And the number in the denominator's place is the root, and the number on top of the 1 is the power. So this says take this number to the nth root and then to the first power, which isn't going to do anything. If a is less than 0 and n is an even number, no real number answer is possible. In other words, you can't take the square root, the 4th root, the 6th root of a negative number, because you need to, if you take 2 numbers and multiply them together, there is no way you're going to get a negative number. So these following problems. A to the 1/3 power is the cube root of a. And if it's not the square root, you just put the root right where the check mark is. 27 to the 1/3 power is the cube root of 27. So what you're asking yourself is what number times itself 3 times makes 27. If you can't figure it out, on your calculator is a key that looks like that. And you should be able to enter your number, press that key, and it should give you the root that you want. You need to explore that. So what number times itself 3 times makes 27? 3 does. 3 times 3 is 9 times 3 is 27. 16 to the 1/4 power is the 4th root of 16. So you're asking yourself what number times itself 4 times makes 16. And that would be 2. And the last one here, this is the 5th root of 32. So what number times itself 5 times makes 32? And again, it's a 2. Note, if I have a negative number to the 1/2 power, for example, negative 25 to the 1/2 power, that's the square root. We don't put the 2 down for the square root. There is no number that exists times itself that makes a negative number. However, the cube root of a negative number does exist. So if I'm asking myself what number times itself 3 times makes negative 27, that would be a negative 3. So that does work. Now the previous problems, the numerator was always 1. The numerator is going to be something other than 1. And earlier I said the numerator indicates what power you're going to take that root to. So a to the 2/3 power is the cube root of 8 squared. The cube root of 8 is 2. 2 times 2 times 2 is 8. And then you square it, the answer is 4. 16 to the 5/2 power, that's the square root of 16. We don't put the 2 in there when we do the square roots. Every other root we will. And that answer then is taken to the 5th power. So the square root of 16 is 4. 4 to the 5th power. Use your calculator. Is 256. Okay, at this time I want you to get your books open to the assignment. And we're going to do the first half, which is on page 553, written exercises 1 to 34. And then the second half, after we go through the vocabulary, is 563, written exercises 1 to 39. So right now we're on 553. And have your calculators handy. I'm going to pull mine up to see if we can, I want to check and see if it's got the, yeah. This one has that key on it, so we'll use it. It's right here. Okay, number 1 on page 553. We have the square root of 6, and they want us to write it as a fractional exponent. Put the base down, which is 6. No power is being taken of that square root or that radical. So the numerator is 1, and it is to the second root. Since there's nothing here, it's always the second root, and there's our fractional exponent. Number 3, the cube root of 11. Again, no power is being taken, so put the 11 down. 1 is the numerator. No power is being taken. The root is the denominator. It was taken to the third root. Number 5, the fourth root of 2. Again, no power. Put the base down 2. 1 is your numerator, which is taken to the first power, nothing else, and the root is 4. So it's 2 to the 1/4 power. Number 7, you have the cube root of -15. The base is -15. Make sure you enclose that in parentheses so you know it's -15, not the opposite. No power first. So put 1 up there, and the root is 3. Number 9, you have the 6th root of 10. So that would be 10 to the 1/6 power. Number 11, you have the cube root of 4, and then that is taken to the second power. The base is 4. The numerator is the power that root is taken to, so put a 2 on top. The root is the denominator, so it's 4 to the 2/3 power. 13, the square root of 2 taken to the third power. The base is 2, the power is 3, so you put that as the numerator. The root is to the second power. 15 is the fourth root of 3 taken to the 5th power. 3 is your base. The fractional exponent, the numerator is 5 since that's the power, and 4 is the denominator, that's the root. Number 17 says to simplify. If the expression does not name a real number, say so. So we have 64 to the 1/2 power. That's the square root of 64, which is 8. Number 19, we have 27 to the 1/3 power. That's the cube root of 27. So let's try just to do one of these on the calculator. Enter in 27. Press the sign there and 3. Let's see what happens. Okay, 3. 3 times 3 times 3 is 27. Number 21. Negative 64 to the 1/3 power. So we want the cube root of negative 64. So what number times itself 3 times? Try this again. Negative 64. Clear that. I seem to be having difficulties here. Okay, clear it one more time. I'll try it and then I'm going to quit. Nah. Don't know what I'm doing. Okay, we'll let that one go. It's negative 4. Negative 4 times negative 4 times negative 4 is going to make negative 64. 23. Negative 1,296 to the 1/4 power. So that means the 4th root of negative 1,296. Well, that's a negative number taken to a even root. So you're saying something 4 times multiplied together is going to come out negative, which is impossible. So there's no solution. An even root of a negative number cannot happen at this moment. 25. You have 32 to the 3/5 power. That is the cube root of 32 taken to the 3rd power. So what number times itself 5 times makes 32? That is 2. Taken to the 3rd power is 2 times 2 times 2, which is 8. 27, 9 to the 5/2 power. That's the square root of 9 taken to the 5th power. The square root of 9 is 3, and 3 to the 5th power is 243. Number 29, negative 9 to the 3/2 power. So we have the square root of negative 9 taken to the 3rd power. That is an even root of a negative number, no solution. Can't be done. And 31. 36 to the 3/2 power. That's the square root of 36 taken to the 3rd power. Square root of 36 is 6. 6 to the 3rd power is 216. And 33, the last one on this page, 125 to the 4/3 power. That's the cube root of 125 taken to the 4th. So what number times itself 3 times makes 125? That's a 5. And 5 to the 4th power is 625. Is working with quadratic equations with perfect squares. A quadratic equation, the largest term has an exponent of 2. And how we're going to work these is to first, like we did with the square roots, isolate the perfect square, and like a reverse of it, take the square root of both sides. And when we do that, we can have a positive and negative answer, and sometimes no answer. So these are the possibilities. It depends on what happens under the radical sign. If the number in a radical is positive, we'll have 2 answers, 2 possible roots. If it comes out 0, well, 0 is neither positive or negative, so there's only 1 root. If the number under the radical is negative, we can't take the square root of a negative number at this moment, so there would be no real roots, no answers. So for the first example, m squared is isolated, so I'm going to take the square root of both sides. And I get m equals plus or minus 7. Since 49 is positive, I have 2 answers, 2 roots. Number 2, the r squared is not isolated, so first divide by 5, and I get r squared equals 9. Now I can take the square roots of both sides, and I have r equals, can be positive or negative 3. 2 answers since 9 is positive. Number 3, the perfect square is isolated. Take the square root of both sides, and I get x plus 6 equals plus or minus 8. Solving for x, I subtract 6 from both sides, and I get x equals negative 6 plus 8 or minus 8. So the 2 answers are negative 6 plus 8, which would be 2, and negative 6 minus 8, which is negative 14. And both of those work. If I put 2 in there, 2 plus 8 squared, I get 64. If I put negative 14 in there, negative 14 plus 8, 6 is a negative 8, and negative 8 squared will also work. Example number 4. The perfect square is not isolated, so divide by 5, and I get x minus 4 quantity squared equals 8. Take the square root of both sides, and I get x minus 4 equals plus or minus radical 8. Now remember, with radicals you have to simplify, so that's x minus 4 equals plus or minus, there's a 4 in there, 2 radical 2. Add 4 to both sides, so x equals 4 plus or minus 2 radical 2. So the 2 answers are 4 plus 2 radical 2 and 4 minus 2 radical 2, and your answer can be left like this. Number 5 is a perfect square trinomial. First term squared, last term squared, in the middle is twice the product of their square roots, twice 3y. So that can be rewritten as y plus 3 quantity squared equals 49. Take the square root of both sides, and you have y plus 3 equals plus or minus 7. Subtract 3 from both sides, y equals negative 3 plus or minus 7. So 2 possibilities, negative 3 plus 7, which would give us 4. 4 plus 3 makes 7, that will work. And negative 3 minus 7, which would give us negative 10. And negative 10 plus 3 gives us negative 7. Square that and I'll still get 49. Number 6, the perfect square is not isolated, so we subtract 15 from both sides. So now we have 2 times the quantity, 3x minus 5 equals negative 8. divide by 2, that's squared, and I get 3x minus 5 quantity squared equals negative 4. Take the square root of both sides, and I stop right here because I have the square root of a negative number, which is not possible, so I say no solution. These are the kinds of problems you're going to be working on your assignment, so you need to open your books to 563, and we're starting with number 1. The directions say express irrational solutions in simplest radical forms. That means you don't approximate. If the equation has no solution, write no solution. Number 1, x squared equals 64. Perfect square is isolated. Take the square root of both sides. X equals positive and negative 8. Number 3, t squared equals 100 over 169. Perfect square is isolated. Take the square roots of both sides. T equals positive and negative. Square root of 100 is 10. The square root of 169, so perfect square is 13. Number 5. 3x squared equals 108. Perfect square is not isolated. Divide by 3. X squared equals 36. Now take the square root of both sides. X equals positive and negative 6. 7. 14t squared equals 126. Isolate the perfect square, divide by 14. T squared equals 9. Take the square root of both sides, and t equals positive and negative 3. Those are our solutions. Number 9, x squared plus 32 equals 0. Isolate the perfect square, so subtract 32. We get x squared equals negative 32. Take the square root of both sides, and I see that I have a negative under the radicand, so no solution. Number 11, 6x squared minus 18 equals 0. Isolate the perfect square, add 18. We have 6x squared equals 18. Divide by 6. X squared equals 3. Take the square root of both sides. X equals positive and negative radical 3. And 3 cannot be simplified under the radical. 13. 4y squared plus 7 equals 19. Isolate the perfect square. Subtract 7. You have 4y squared equals 12. Divide by 4. Y squared equals 3. Take the square root of both sides. Two solutions are y equals positive and negative radical 3. 15. 3z squared minus 18 equals 3. Isolate the perfect square. Add 18. 3z squared equals 21. Divide by 3. Z squared equals 7. Take the square root of both sides, and z equals plus or minus radical 7. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 17, the quantity y minus 6 squared equals 13. The perfect square is isolated. Take the square root of both sides. Y minus 6 equals positive and negative radical 13. Get the y by itself, add 6 to both sides, so that would be y equals 6 plus radical 13 and 6 minus radical 13. You can write your answer like that. 19, s minus 7 quantity squared equals 28. Perfect square is isolated. Take the square root of both sides. So you have s minus 7 equals, and you're going to have to simplify that radical, that's 4 times 7, plus or minus, the square root of 4 is 2, radical 7. Move the 7 to the other side, or add 7 to both sides, so s equals 7 plus 2 radical 7, as well as 7 minus 2 radical 7. Number 21, 2 times the quantity x minus 5 squared equals 18. Isolate the perfect square. So you have x divided by 2, x minus 5 quantity squared equals 9. Take the square root of both sides and you have x minus 5 equals plus or minus 3. Add 5 to both sides, so your two answers are 5 plus 3 or 5 minus 3. 5 plus 3 is 8, 5 minus 3 is 2. So both of those numbers, if you substitute back in, will make a 3. And when you, or a negative 3, and when you square it, you get 9. Number 23, you have 8 times the quantity x plus 3, quantity squared equals 56. Isolate the perfect square, divide by 8, and you get x plus 3 quantity squared equals 7. Take the square root of both sides, and you have x plus 3 equals positive and negative radical 7. Subtract 3 from both sides, you have x equals negative 3 plus radical 7, and x equals negative 3 minus radical 7. So those are your two answers. If you are only assigned section A, you can stop and work on the evens. Number 25. We have x squared plus 6x plus 9 equals 16. That's a perfect square trinomial. So that'd be x plus 3 quantity squared equals 16. Take the square root of both sides, and we have x plus 3 equals positive and negative 4. Subtract 3 from both sides, so you have x equals negative 3 plus 4, and x equals negative 3 minus 4. Negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. Both of those numbers, if you put them in, will make a 4 or a negative 4, which is what we want. 27, you have r squared minus 22r plus 121 equals 4. That's a perfect square trinomial. The ends are perfect squares, so we factor. It's r. Square root of 121 is 11. The middle is minus, so minus 11. Quantity squared equals 4. Perfect square is isolated. Take the square root of both sides. So you have r minus 11 equals plus or minus 2. So r will equal, add 11 to both sides, 11 plus 2 and 11 minus 2. So your numbers are 13 and 9. And those will solve the equation. Number 29. You have 1/5 x squared minus 5/49 equals 0. isolate x squared. So we have 1/5 x squared equals, add 5/49 to both sides, 5/49. Multiply by 5, and we have x squared equals 25/49. Take the square root of both sides. X equals positive and negative 5. Square root of 25 is 5. Square root of 49 is 7. I'm going to change the assignment to 30. I'm exhausted. So this is it. Enjoy. And we'll see you Monday.